So we're going to start off today with word problems, starting off with angle of elevation and depression. I'm going to start off by saying, just knowing these are both the exact same thing. Angle of elevation and depression are the exact same thing. And if you refer to these kind of as like the reference angles, you're going to deal with the same situation, that it's always the angle between kind of your hypotenuse and the horizontal axis. So angle of elevation, we're talking about from like a line of sight that's horizontal, and you're going from there to that hypotenuse. So that's an angle of elevation. Angle of depression is doing that same horizontal line of sight, but you're looking downward, which is why it's a depression. But if these two horizontal line of sights are parallel to each other, that angle of depression is equal to that angle of elevation. These two angles are exactly the same, no matter what. The worst thing you can do is draw your angle of depression or elevation from a vertical. So if you kind of do what we've been doing with reference angles and drawing that kind of angle, you can kind of help out here. Like for example, this example here. So I already kind of drew a triangle out just to save time. But we have Ashley that is 15 feet away from the flagpole. So we can say that Ashley is right here. This is her line of sight. The angle of elevation to the top of the pole is 39 degrees. So if you go from her horizontal line of sight and look upwards, that's the 39 degrees. Again, coming from a horizontal. If you draw it here, that's not from a horizontal. That's from a hypotenuse or from a vertical. So you can't put an angle here. It has to be down here. And again, angle of elevation and depression end up really being the same angle measure. So she's 15 feet away. So I'm going to put that 15 feet here. And we're looking for how tall the pole is. So since we don't have the hypotenuse, this is an easy problem to know which trig function to use. If you don't have a hypotenuse, you have to use tangent. So we're going to do tangent of the angle measure equals the ratio of the opposite side over the adjacent. So the opposite side is x. The adjacent side is 15. So we multiply both sides by 15. And I usually like to have it as a coefficient in front. And then you put it into a calculator. So with me at home, I have a graphing calculator. If you have a scientific calculator, this works as well. So if you ever want to reset it, again, that's second plus sign 712. That allows everything to go away if for some reason you're messing around with it and you want to make sure that everything is right. Second plus sign 712. What's nice about these newer calculators is that it kind of tells you a lot of information up here. One important thing you want to make sure you do is change it from radians to degrees. So if you go to mode and go until you highlight degree and press enter, you're now in degree mode. We're going to talk about radians pretty soon, but a very big thing is having angles in degrees. So make sure that you're in degree mode. All right, so then we'll just quit that and type in what we have, 15 tangent of 39 degrees. And you end up getting that the flagpole is 12 points. Let's see, rounding to the nearest tenth. So 1 feet. So rounding correctly, putting units, all that is very important. Now, I'll say this here, but don't double round. Double rounding, I've had a couple people telling me about. They're like, oh, well, that 6 rounds the 4 up to 5, and then that 5 rounds it up to 0.2. No. You're looking at the number just like this. Rounding goes, if you're doing to the nearest tenth, you look to the place next to it. That's 4, so you just leave it alone. If it's 5 or higher, it rounds up. All right. Degree, minutes, seconds versus decimal degrees. So degree, minutes, seconds are historically a more accurate measurement of location. So when we're talking about minutes, this is minutes here. We say that there are 60 minutes in a degree. So you can almost think like if you're looking at a clock, 60 minutes is 1 full hour. So you can think of 1 full circle. So 60 minutes is 1 degree. Now this here, these double ones are seconds. So that's that. So 60 seconds is in 1 minute. So if you wanted to kind of compute how many seconds is in 1 degree, well, that's 3,600. Just to kind of put those together. All right. So how do we convert these? So here we have a problem where it's 64 degrees, 32 minutes, and 47 seconds. Mathematically, the way I would do this is take kind of like mixed fractions. We have our whole degree. We have a fraction of a degree, which is 32 minutes out of the 60 that we have. And then we have 47 over how many seconds there are in a degree, which is 3,600. Now, you can do this every single time, or what's nice is that we have a calculator. So, in the calculator, above apps, right here is angle. So what we can do is we can type in 64. We want to do that first. Go to second apps, and notice how we have those symbols. So we have the degree symbol. We have 32, and then go back to the angle, minutes. And then we have 47, and then if you notice, there's no seconds. Well, what you actually need to do is look above the plus sign. In whatever alpha color you have, blue or green or whatever, you have the seconds button. So you press alpha plus sign and you get the seconds. So that is the decimal version of this. You could also have done it where 32 over 60 plus 47 over 3,600 and get the exact same answer. So either method actually works. And if you have one of these graphing calculators, it works. You should have an angle section no matter what. On TI calculator, you have the scientific as well. Has, I think, a little bit better of a situation there. So this degree minute seconds translates to this. Now, what about going from degrees to degree minute seconds? Well, if you had noticed, so let's type in the number 64.5463 and then just repeating eights. I don't think that there really matters how many, but if you go back to that angle situation and go to number 4 and go to DMS, and again in the scientific calculators they do that as well, and you press enter, there it is. This is 64 degrees, 32 minutes, and 47 seconds, which is exactly what part A was. And you can kind of see, like, if you were to keep going, it rounds in the calculator, but that's the repeating 8. So that's how to go from that. So let's look at some more examples. Let's do this again. So if we're converting this to decimal form, we're going to do 121, go to second apps, get the degree, 42, go to second apps, get the minutes, and then 58 seconds is alpha plus sign. And there it goes. It's approximately 121.716, and we can say that's a repeating 1. And then, again, if we're going from degrees and we wanted to change it to degree minute seconds, we go to second apps and then DMS, and there it goes. So it's 34 degrees, 45 minutes. And this was not as precise as with having a whole number kind of seconds, but that's how you do that. Converting from degree minute seconds to degrees and vice versa. Here is a quick brief introduction to trig identities, where we're going to get into them later on, but we're going to kind of stay basic right now. So trig identities are kind of proofs, but it's not like geometry proofs where you have to state the reason and all that stuff. You just need to be able to show how the left-hand side becomes a right-hand side. And there might be times where you get to choose to change the right side to be the left-hand side. So you kind of just need to know your identity rules. So my suggestion for making trig identities easier for you and less challenging is to get them in terms of sine and cosine. So sine is already in terms of sine, so I'm going to leave it as sine. The operation between sine and cosecant is multiplication, but cosecant, how do I get that to be in terms of sine? Well, it's the reciprocal of sine, so I'm going to do 1 over sine. Something that you're going to need in calculus is being able to show your steps and have an equal sign for every single one of those. Well, what happens when you multiply something by its reciprocal? Well, they cancel each other off and you're left with 1, which is equal to the right-hand side, so there's your proof. That's trig identities. What about cosine times tangent equals sine? Well, again, my suggestion to you is to get these in terms of sine and cosine. You don't want to change cosine to secant, which is the reciprocal. It is or 1 over secant, which is the reciprocal, which, you could do that, but let's just leave it in terms of cosine. But then how do I get tangent to be in terms of sine and cosine? Well, if you remember from the unit circle, tangent is y over x. Y is sine, cosine is x. So I can replace tangent with sine over cosine. And remember that we need to show our work and put an equal sign in each one. Well, what happens if I multiply cosine by something divided by cosine? Well, they become 1. They cancel each other off. So you're left with sine of theta, which is the proof on the right-hand side. So every single one of your trig identities should end with this line where you show the left-hand side equals the right-hand side. Talk about how to use the calculator to do some of these problems. And some of these questions are really that easy. All you have to do is make sure you're in degree mode, and we're just going to type in cosine, which is right here. So cosine of 23.4. You don't really have to close a parenthesis. Some calculators are very particular about it, but you press enter where it says round to 4 decimal places. So this is 0.9178. Okay. All right, what about the next one? Well, the next one is secant of 23.4. Well, secant is a reciprocal of cosine. So that means if I want to type this into the calculator, I need to do 1 over cosine of 23.4. So you can do 1 over, and then with the newer calculators, you can actually go up and copy paste, highlight whatever you want, press enter, and there it is. So there's secant. You could have also done 1 over that answer, got the exact same answer. So this is 1.0896. Well, what's nice is now that we know about degree minute seconds, we can actually type this into the calculator like that. So tangent 43 second apps degrees, 15 second apps minutes, and 47 alpha plus sign, and there it goes. So 0.9411. What about sine of 66.6? So sine of 66.6, you get 0.9178. Hey, that sounds familiar. Isn't that the same answer to that? Yeah. If you notice, 66.6 and 23.4 is what we call complementary angles. That means both of those are added up to each other. So these two come out to be the same answers because these are called cofunctions, and we'll talk more about those later, but just something to see. So how do we do cosecant if that's the reciprocal of sine? Well, just for the notes, I'll write it out. It's 1 over sine of that same angle, which we should know what the answer is because we've already done this problem, because it's just, again, a cofunction here. 23.4 and 66.6 are complementary angles. So 1.0896. And then what about cotangent of 46 and blah, blah, blah? Well, we don't have a cotangent button, but we'll do 1 over tangent of all of that. Get 0.9411. Which looks familiar because it's also the same answer for 3, because if you were to add these two together, they're going to add up to 90 degrees. They're complementary as well. So these two are also what we call cofunctions. All right. Now, what we're going to do here is figure out how to get the original angle measure depending on giving us a ratio. So what we want to do is kind of build some rules. So if you're dealing with sine, just like number 1, what we want to do is we're going to inverse sine our ratio, and what we're going to end up doing is getting an angle in the calculator. Now, this is a rule, and we can talk about it later of what it happens, but to get 2 angles using sine, what we do is we get its angle and we get its supplement. Well, if you're given an angle and you're trying to find its supplement, what you do is you take it away from 180. So this is what the calculator gives you. And what we do is we also need to figure out its supplement to figure out 2 angles. Well, for cosine, what we're going to do is we're going to do cosine inverse. And what's nice about this one is that all we need to do is get plus or minus whatever the calculator gave us. Okay, so the calculator gives us a certain answer, and we add the plus or minus. Tangent, what we do is we put that in the calculator, we get an answer, and what we need to do is add some multiple of 180. Maybe subtracting, I just put that just in case, but we're going to have to add 180 degrees, some multiple of it. It could be one of them, it can be 2 of them, however many times we need to get into the range of answers that we have. So this is stuff to write down just to make sure, and we'll look at some examples of how this actually applies. So we can also talk during notes or something if you want to know why. All right, so sine of theta equals this ratio. In order to get this theta to be itself, what we need to do is inverse sine both sides. When I inverse sine, I just get the angle on the inside. So I'm going to inverse sine both sides. Now again, making sure that your calculator is in degree mode, we're going to type that in. Now, just a food for thought, sine inverse is not the same thing as cosecant. Cosecant is a reciprocal. Sine inverse is the inverse. We use inverse sine to find angle measures. So let's just put that into the calculator. So I'm going to press second sine because it's the blue above the sine button. And we're going to type in that decimal number. And we get our answer. So, doesn't say, so we're just going to round to 4 decimal places, just like what it said at the very top. So 55.962. Okay, degrees. Degrees are units, so make sure that's always on there. So for the notes, I'm just going to say that's what the calculator gave me. Now, in order to find the second angle given this one, we need to find its supplement. So to figure out its supplement, we do 180 minus, and try not to use the rounded value. That's going to be something very important later on, but you always want to use as many decimal places as possible. So we're going to go up and copy what we just got from our answer and figure out our second angle. So 124.0038 degrees. So those are our 2 answers. Now, what I always suggest to do is check your work. If you take this data that you figured out and you plug it back in a sine, what should you get? Well, let's see. That's pretty close to what we gave you. What about the next one? Sine of 124.0038. Oops, forgot a number. There it goes. Pretty easy to just check your answers. It takes like a second to just type it back into the calculator and make sure your answers work. All right, secant. You can look all through your calculator, but there's no secant inverse button. What we do have is a cosine button. So what I need to do is figure out how to make this a cosine function. Well, in order to make this a cosine function, I need to do the reciprocal of both sides. So if I do the reciprocal of secant, I get cosine. If I take the reciprocal of 3.420, I get 1 over that. So in order to figure out what theta is, I inverse cosine both sides. So I'm going to do cosine inverse of that fraction. Now it's very important where this fraction is. If you try to put that fraction on the outside, let's see what happens. Is it 3.420? Error. If you get an error, you probably did something wrong. So make sure you know exactly how to type this in. We need to do second cosine and put the fraction inside of the function. And we end up getting our answer. So for cosine inverse, like the rules we said on the top, on the bottom, our two answers are just plus or minus this. Now, if we didn't give you any restrictions on your answers, box that in and you're done. However, we need to find two angles that are between 0 and 360. Well, 72.998, oops, I rounded 4 degrees is one of the answers. That's in there. But what about negative? What do I do with this negative 72.9984 degrees? I need to make that the same thing, the same angle, but I need it to be a different measure. I need it for it to be positive. Well, something that you have been taught now is what coterminal is. Coterminal is adding or subtracting a circle to get a different angle that has the same measure. So what we're going to do is we're going to add 360 degrees to this negative answer. So what I'm going to do is in the calculator, I'm going to take negative. I'm going to copy and paste that answer and add 360 to it and get 287.0016 degrees. So those are your two answers between the range that was given. And again, take a few seconds and check cosine of that angle. That's cosine, so it's 1 over cosine of that angle. That's pretty close. 1 over cosine of that other angle that we got. Pretty close. Okay. Even if you had put the negative of that in there, let's see what happens if I put negative 72. It's the same answer. Okay. I mean, it's kind of different back here, but it's pretty close, 3.420. So check your answers. All right, same idea. So we have tangent. We actually have a tan inverse button, so I don't have to do any kind of reciprocals. So I'm going to do tan inverse of whatever that ratio is that we gave you. So let's type that into the calculator. Oops, and we get our answer. So negative 60.4528 degrees. Okay, wait a minute. That's outside of my range. So that's what I was talking about with our rules, that if you have tangent, we get what the calculator does, but what we need to do is add multiples of 180. So we're going to add 180 to that and get an answer of 119.5472 degrees. Well, I'm supposed to have two angles. So I'm going to add another 180 to it and get 299.5472. So there are my two angles that give me that inverse. And again, you can check your work, tangent of that and tangent of that. Pretty close to the ratio that we gave you. Now again, we can talk about y and all that stuff, but really you just need to know the rules. That when you're using inverse sine, you get what the calculator gives you, and then you figure out its supplement. The supplement is always in this order, not subtracting 180, but 180 minus theta. Cosine of theta, we do plus or minus whatever the calculator gave you. And then tan inverse, we're going to get what the calculator gave us, and we're going to add however many 180s I need to in order to get two answers that are within the range of values that we want. All right, so last problem here, cosecant. We don't have a cosecant inverse button, so we need to change it to sine. So when I do that, I need to do the reciprocal of this ratio. So now I can inverse sine both sides and make sure that the fraction goes on the inside. So let's see what the calculator gives us. So second sine 1 over negative 2.5123. So we get negative 23.4558 degrees. So again, this is what the calculator gave us. What I also need to do is figure out the supplement. And just because it's negative doesn't mean to change anything. You literally just do 180 minus that angle and get 203. Oops, forgot the 3.4558 degrees. Now, I could box in both of these answers and say that I'm done, but I can't leave my answer like this. I need to add 360 degrees to it. So let's go get that answer and find its coterminal, positive coterminal angle, which is 336.5442 degrees. So these two would be my answers. So again, be very careful with rounding. If you're doing a quiz or anything like that with us that asks you to type them in, there's no margin of error. You need to make sure that you type it in exactly as it's supposed to. See ya.